So antiderivative is the same as an integral. So we're going to do the power rule on each term. So I'm going to do the antiderivative of this guy plus the antiderivative. On this one, I'm going to change it to 1/4 times x to the negative half. You guys see where this came from?
Because it's in the bottom.
Yeah, it's a 1/2 power. I brought it to the top, right?
Mm-hmm.
So this is a negative power now. The 4 is still down here. That's why I wrote it as a 1/4.
Mm-hmm.
We could completely pull that out, right? It's one of the rules.
Yeah, one of the
Or
rules
what?
to pull any constant. So let's just do the power rule here. So that's going to be -5 plus 1 over -5 plus 1. This guy will be plus 1/4 x to the negative half plus 1 over negative half plus 1. Right now it looks all funky, so let's fix it. So we got -6 as your, or sorry, -4 here over -4 plus 1/4. -1 plus 1, that's going to be a half, right? So at this point, you can write it as a, if you prefer, you can put the 4th in front. You can divide the 1/4 by the half. That'll be the same as doing the reciprocal, right? That would be, I believe it's 1/2, yeah. So at this point, we're pretty much done. Although the answers don't have negative powers, you usually fix this. Just bring it to the bottom. So you have a -1 over 4x to the 4th. And then you can put the 2 down here as well if you want. Oops. The 4 I meant. So this 4, you can just put it along right next to that x to the 4th. This one I would just leave it that way. Although the answers might use a square root. I don't know. But you don't have to change it to square root. Yeah, they didn't. So yeah, here it is. Oh, sorry, this one. Any questions on any of the steps? Is that okay? Okay, let's go to the next one, number 3. Number 3 is similar. Let me see. Yeah, we can do that one. It's not, it's really short, so let's do 3 and 4. Okay, so find the antiderivative of 8. They use t, so I'm going to change it to x's. Dx. So integrate this guy. That would be 8x to the 2 plus 1 over 2 plus 1. Integrate this guy, you'll get x to the 1 plus 1 over. So that 10, you can, well, you know what, let me show an extra step just in case. So it's not weird. So separate them first. Then you can pull out the 8 and the 1/10 in front, so it's not confusing. And you don't have to. I mean, you could go straight to the power rule. At the beginning or whatever. So power rule here, you'll have 8x to the 2 plus 1 over 2 plus 1 plus 1/10 times x to the 1 plus 1 over 1 plus 1. So at that point, we're pretty much done. That's going to be a 3. So we have 8/3 x cubed plus 1/10 x squared over 2 plus c. But we can multiply that out, right? So 8/3 x cubed plus 1/20 x squared plus c. Any questions about the power rule for antiderivatives?
Hold on, before we move, let me just write down.
Do you have a question, Felipe? I didn't catch it.
No, I'm just writing it down before we move on. Give me just a few
Yeah.
seconds.
It is that y on the 8/, radical y.
Yeah, it's square root y on the bottom. Square root y on the top here. 8 over square root y. Okay, so I recommend separating them and changing the square root into powers before you start. But before we start number 4, you guys are good on 3?
Yes, sir. Thank you.
Okay. Alrighty. So separate. So I'm gonna have y to the 1/2 over 8 dy plus 8 over y to the 1/2 dy. So I'm gonna bring that y to the top and pull out the constants in front. So I'm gonna have 1/8 integral of y to the 1/2 dy plus 8 integral y to the negative half dy. Okay.
And you said that that negative one, the power negative, the negative power of 1/2, even if it is on top, we have to move it down, it'll still come up with a negative, right?
Yeah, if you brought this one to the bottom,
The second term, the 8 over y 1/2.
no, either way. If you move this to the bottom, it turns to negative. If you move this to the top,
Okay, yeah,
it turns to negative.
yeah. All righty then. Mhm.
So it applies both directions. So at that point, you just integrate each piece. And we get y to the 1/2 plus 1 over 1/2 plus 1 plus 8 to the 1 times y to the negative half plus 1 negative half plus 1. All right, I'm running out of space, so that'll be 1/8 y to the 3/2 over 3/2 plus plus. Let me make space here. Okay. So we'll have 8 to the y to the 1/2 over 1/2 plus c, which will give us 8 times 2/3 times y to the 3/2 plus 8 times 2 times y to the 1/2. So final answer would be that result. Yeah. Double check everything.
I don't think the answer matches.
This one's good. This one seems off. Let me see. There's 1/2 plus 1.
Was that supposed to be a negative 1/2?
The first one should be positive
Okay.
because it's a square root on top, right? Oops. If you have 1/2 plus 1.
I think that the a is supposed to be 1 over 8.
Oh, yeah. Thanks. I don't know how it became a 8. So multiplying this guy, that gives the answer of 1/12 y to 3/2 plus 16 y to 1/2. But anyway, I'm pretty sure you guys can do fractions. The main part is right here, right? So that's what they get, the 1/12 and the 16. You just need to change these to powers first and get anything on the bottom to the top. So always start this way. If you have a variable on the bottom, make sure you move it to the top before you start in the antiderivative step. Any questions on 4?
Can you go back to the notebook? I need to finish the.
Oh, sorry. Yeah.
Yes, thank you. Where you get the 12 over there in the last line? Gives me that again.
Oh, sorry, I was muted.
Yes.
Yeah, when you multiply across, or you can cancel the 2 and the 8, so that'd be a 4. So 4
Okay.
times
Oh,
3.
4 times 3. Okay. All right. Thank you.
Yeah. Any questions on 4? Any other questions?
Nope. I want to know how to do 5 though.
You do or don't?
I do want to know.
Oh, okay. Okay. Let's do it. So this is what I was talking about. You need an initial condition to find your C. So we need to find the constant, this guy here. So everything will be the same. There'll just be an extra step at the end where we use that initial condition. That's it. All right, number 5. So solve the initial value problem. dy dx is equal to 1 over x cubed plus x. And they say that x is greater than 0 and y of 1 is our initial condition, gives us 2. So what you got to do basically is integrate dy dx, which means integrate this function with respect to dx, or x rather. So we're going to solve this guy, because that would give us y. So y is equal to that result. So integral of a derivative is just the original function. So that's why this is gone. So y is equal to this. So let's change this into a negative power and integrate. So y, the original function, is equal to these two. So power rule will give us x to the negative 2 over negative 2 plus x squared over 2 plus c. So y of x, the function, is equal to negative 1/2, actually negative 1 over 2x squared plus x squared over 2 plus c. Okay, so we need to solve for c. So use this guy to solve for c. So plug in 1, and when you do, it's equal to 2. So y of 1 would give me negative 1 over 2 plus 1 over 2 plus c, and that has to be equal to 2, because y of 1 is equal to 2.
Professor, but how do we get that 2x squared on the 1 over 2x squared?
How we got from here to here?
Next
The next one.
line, right there, equals, and then negative 1 over 2x squared. How do we get that 2?
Oh, this one?
No, the
The
other
other one
one
at the top. At the top.
on top of that one. The second from the last.
I think the x squared over 2.
That one, yes,
Where did this come from?
to the left. Sorry, the first, that one right there.
Oh, you just bring the x squared to the bottom. So yeah, it's -2.
Okay,
So I bring it down and make it positive. Because I can bring this up to the top anytime I want, right? To make it negative.
okay.
So I can bring it down as well. Using that property. Remember the one I showed you last time?
Yes, yes, yes. So okay, I got a little confused because you brought, there's a 2, there's a 2 and then the x squared.
Yeah, the 2 is still here. So I brought that 2 right there. Or sorry, the x -2 became x squared.
Okay, I see now.
Is this step okay?
Mhm.
Okay, so notice how these are going to cancel, right?
Yes,
So what is c equal to?
the 2.
Yeah, c is 2. Given this condition. So with that initial condition, our general function will be -1 over 2x squared plus x squared over 2 plus 2. No more c. Any questions on the notation or the steps?
Oh, I got it. Okay.
You comfortable with this right here?
Yes.
You guys notice it's the same as this, right? 1, 2.
Okay,
When x is 1, y is 2. So you set it equal to 2 and plug in 1 to solve for c. That's what we're doing. Okay.
Is there going to be any graphing involved in anything on the test?
No.
Okay.
But, well,
the last one has a graph, but not much.
yeah, I mean, you might have to find area underneath a curve. So graphing might help you, but it might not be necessary. And yeah, 13 gives you the picture, so it's kind of nice.
Okay.
But no, I don't think so. I don't think you'll need a graphing. Okay. Write the sum without sigma notation. Okay, so you use a sum from 1 to 2 of 4k over k plus 9. Since we only have 2 terms, we can just plug it in, right? So start at 1, 4 times 1 over 1 plus 9 plus 4 times 2 over 2 plus 9. So it'll be 4 over 10 plus 8 over
18.
which is 62/55. Yeah. So all they wanted to do is plug in the numbers. So there's what we did here. They didn't even add this up, but anyway, there it is. Any questions on the sum? And it seems pretty straightforward, but
Okay, yeah, I'm gonna, yeah. Never mind.
number 10, evaluate the integral from 2 to square root 10 of z minus square root 10 dz. So that'll be the integral of z dz minus the integral of negative root 10 dz. So that'll simply just be z squared over 2 minus should only be 1 minus. That's just a number. So you're going to get negative square root 10 z from 2 to square root 10. So just plug in the numbers. It's always the top minus the bottom. So square root 10 squared over 2 minus square root 10 times square root 10 minus 2 squared over 2 minus square root 10 times 2. Okay. So that'll be 10 over 2. This will be minus 10 minus 4 over 2 minus will be plus 2 square root 10. So that'll be 5 minus 10 minus 2 plus 2 root 10. So final answer should be, what is that, negative 7? I hope. Yeah, that's what they got. So any issues with the integration or evaluating the bounds or the algebra?
No, not really.
All right. So number 11 is the same deal as maybe a little easier. So let's move on to 12.
Can you go back to it really, really quick? I just want to see
Yeah.
the bottom.
No rush. I'm sorry.
Okay, thank you.
One second. So we were going to 12. We'll find the total area between the curve and the x-axis.
Is the test gonna be same time as previous tests? The limit time, allowed time, or whatever.
I think it's 60 minutes.
It's an hour. I'm staring at the
Oh,
screen
wow.
for it.
So it's less. Okay.
Yeah, it's less.
But it's pretty short though.
Yeah. 10 questions, right?
I think I removed one. I think it's 9 or 8.
Right.
Curve and the x-axis. All right, so here's the function. 9 over x cubed from we're from 1 to 3. So all you have to do, so these are the bounds of integration. So you integrate from 1 to 3 of 9 over x cubed. So since they said it's between the x-axis, I can do it straight up just like this. So just integrate this thing. So I'm gonna pull out the 9 and bring up the x cubed. Okay, so then this will be x to the negative 2 over negative 2. So negative 9 halves x to the negative 2 plus c. Fix this number here, this power. Oops, sorry. There is no c because we got bounds. My bad. From 1 to 3. Okay. So I'm gonna go ahead and rearrange this guy. So it'd be negative 9 over 2x squared. So I skipped a small algebra step. Is that okay? Do you see how we got here?
Yeah, I can see it.
All right, we just brought the x squared down, put the negative in the front. That's it. So now let's plug in the 3 into that x squared. And then minus, plugging in the 1. That's our fundamental theorem of calculus.
Shit.
So it'd be 9 over 2 times 9. Minus minus, that'll be plus 9 over 2. Right? Squared, 3 squared is 9. These 9s will cancel, leaving me with a negative half plus 9 halves, which is 8 halves, which
Okay, that
is
was close.
4. Any issues with the antiderivative or evaluating the bounds? Does that make sense?
What sentences they can make given what it is.
On the second to the last part, it's 2 times 9.
Yeah, 2 times 9.
Okay.
Let's look at 4.
But these 9s will cancel, right?
If I recall correctly.
So it leaves you only a half. Because when you cancel, you got to leave a 1.
Mhm.
Yeah, any other
Uh,
questions?
Not about this. Oh shit, damn, those jalapenos are coming back to bite me.
Let's do the 13. Yeah, so the last one. I removed the ones with the triangles. You shouldn't come up. Since we didn't really talk about it too much. And if you took it already, then I won't hold that against you.
With any luck, since you did the adjustment, I'll have it done. I can do it tomorrow.
Okay.
Oh shit, I'm unmuted.
So find the area of the shaded region. Okay, so see how it's bounded by the x-axis and the curve? So all I have to do is integrate this function on dx, or respect to x, I mean, from 0 to 2. So that's where the boundary ends. This is where it starts. So I'm integrating from 0 to 2. Okay, so integrate 0 to 2 of the y function, which is x squared plus 3. It's my f of x. So once we have this idea, or it's pretty easy, right? Just separate it like we did before. Do the power rule on this guy. So the x 2 plus 1 over 2 plus 1 plus 3x from 0 to 2, which will give us x cubed over 3 plus 3x from 0 to 2. So that'd be 2 cubed over 3 plus 3 times 2 when I plug in the upper bound. And then minus, plug in the lower bound, it'll be 0 plus 0, which will be 0, right? So final answer should be 8/3 plus 6, which is about 8.7, I think. Yeah, that's right. Any questions from the review that didn't make sense? Or maybe you missed something?
Pretty much, that's it. Mhm.
Just a second, let me double check something. I just finished doing the review, so let me look at my stuff to see what I got.
But don't take too long.
Oh, it's just a quick overview. I had to wait for the screen to load. Let's see. Okay, well, I got about a 50 on it, so not bad. Okay, so I jacked up questions 5 and 6, along with 5 through 8, correct? Correct, on my bad. So,
I have a question.
What's up?
go ahead.
Well, so on the homework for area, the 5.2, on the last 2 questions, it had a question about limit n to infinity.
Mhm.
And I was kind of confused on that one. Will those be on the test?
I don't think so, but let me check.
Also, could you go over it?
Yeah, we
Yeah,
can-
like the last one, that one, like, had me pulling my hair out for a little while.
what section was it you said?
5.2.
Okay. 1 second.
As you check, Professor, can you just listen real quick? I'm coming back next Wednesday.
Mhm.
There's not gonna be a review for the final, right? We just take it.
Yeah, you'll just have to take it.
All right, all right. Yeah.
Also, there might be a video already there, but if not, I don't remember. Let me see. Yeah, I have I have the solutions, but I don't have a video of it. Let me see. But the solution goes step by step, so I'm hoping that's helpful since it's stuff you've done before.
It was like the last video in the modules really helped me with that problem.
There was a review for the final video.
Oh, I thought we were just gonna talk about that homework question number 5T15.
Oh no, not yet. We go do that right now. 5-2. The last question you said.
Yeah.
Ouch. These right here, right?
Yeah.
Okay. We just need to use those formulas, but first we have to make it look a little pretty. Let me grab those formulas 1 second. Actually, they might be right here.
Actually, at this rate, I have an earlier day tomorrow than I had today. So I'm gonna go ahead and punch out since we finished the review and I'm done with the review. I think I know what I did wrong.
Well, see. See you when I see
Okay,
you.
I'll see you. Expect a phone call from, let's just say my mama.
Okay.
She I forget the message she wanted me to pass on to you. So she might wind up calling you because she was pretty peeved, she was pretty adamant that you get the message.
Sure. Yeah, I'll talk to you.
Okay, thank you.
See you, Tyler.
Oh, see you, man. See you guys. I hope you guys are successful in your future ventures.
Thank you, Tyler. Be careful.
Good luck, man.
See ya. Adios.
Adios.
Bye.
I find the sum. So we have a limit as n goes to infinity for the summation. The equals to 1 to n times 4 plus I over n times 6 over n. All right. So we're gonna have to separate them and try to factor stuff that's in the way. So the n's can be pulled out. Let's see here. It's a good way to approach it. Yeah, see how there's an n on the entire thing? So we can pull out the 6 over n. So the 6 is a constant, so I can pull that over out of the entire thing. But see how the limit is applied to the n? So I can't pull the n all the way out. I can only pull the n up to here using the summation properties. So now all I have to deal with is this right here. So I'm going to separate this into two sums using the properties of summations. So I'm going to put parentheses, so the sum plus the sum of the second term so the 4 is going to be an easy one, right? The sum of this guy is just 4n. Remember how we said the sum from I to n of a constant would be that constant times n. So that was like the first formula they gave you. So before we do the limits are the last thing we do. So don't mess with the limit. So this becomes 4n. So now I have to deal with this guy. So I can pull out a 1 over n out of this one and deal with the I. I remember we had a formula for when you had AI. Excuse me 1 second. Yeah, I had to sneeze. All right, so the I, this will become, how was it? N times n plus 1 over 2. Yeah. So it'll be times n plus 1 over 2. So notice I've taken care of these sums by applying the formulas to each piece. So this was one formula right here. This one was another formula. Are you guys familiar with those summation formulas? Do you remember them? I give you a list.
Yeah.
Okay. So at this point, I would reintroduce the n and then take the limit. Although I see that, well, no, that's fine. I'll do that in a sec. So if I multiply the 1 over n through all the terms, I'll be left with a 4, right? Because these will cancel, plus 1 over n squared times n times n plus 1 over 2. And I'm going to go ahead and distribute that so you can see it a little more clearly. So it'll be 4 plus n squared plus n over 2n squared. Now you see when I take the limit will have no effect on the 4, right? There's no n here. It's just going to be 4. This guy has the same degree top and bottom, so this limit will become 1/2. So I'm going to end up with 6 times 4 plus 1/2 when you take the limit. 4 plus 1/2, what is that? 9/2? What's 9 times 6? 54?
Yeah.
All right. So I don't like numbers anymore. There we go. Which will be, what's half of 54? 20. So,
27.
all right, so this is my sum. Is there any steps that were strange?
They made sense to me.
Okay. You guys see where the formulas happen, where the algebra happened, and when we took the limit. Is the limit clear?
Yes.
Okay. But so when you do these, what I recommend is don't do the limit to the very end. Try your best to create a situation where you can apply your sum formulas. Once you do that, you can take the limit without issue. Okay, that's the strategy.
Okay.
Do you have any other questions?
Yes, can you go either 7 or 8 from the review we just did? I think it's just the way it's worded that's kind of throwing me off.
I think I removed those.
Oh, you did?
The rectangles, yeah.
Yeah, you don't have to do those.
Okay.
Would you possibly can do quick number 11
From where?
test review?
Let me see. Yeah. 11. Okay. All right, integrate from 0 to 2. 3x squared plus x plus 5 dx. So 0 to 2, 3x squared dx plus 0 to 2, x dx plus 0 to 2, 5 dx. So this will just be 3x cubed over 3 plus x squared over 2 plus 5x from 0 to 2. So then just plug in the bounds, the top minus the bottom. So you're going to get, those 3's are going to cancel. So you're going to get 2 cubed plus 2 squared over 2 plus 5 times 2 minus, it's all going to be 0, right? So you can get 8 plus 2 plus 10. It's 20.
Perfect. Thank you.
Any other questions?
We got a question to ask you after we finish.
Sure.
Private.
How many questions does the final has? Do you know?
Let me check. It's like 50. I'm just kidding.
Dang. I would say I'm gonna see you again. semester. I actually will see you. I'm one
Well,
of
I'm gonna see you personally.
That's true.
I'll too.
You got it. You got your seat, Felipe.
Yes, sir. I think
All right.
I was one of the first ones.
Yeah.
It's 10 questions.
That's the final.
Yeah.
How many questions we have in the final?
10.
Only 10.
What? I'm sorry.
But there's 10 questions on the final, but they're from all topics we've discussed.
They're not gonna be in order, right? They're gonna be like scattered.
It might be. Oh, I already closed it, but
That's fine, that's fine.
it looked like they were.
Alrighty then, I guess this is it, right?
I guess so. We'll see you in a couple of weeks or months, I guess.
I'll see you at the other side.
Yeah.
Alrighty, you guys.
Yeah.
Well, it was
All right,
nice.
Felipe. Good luck. I'll
Good
see you
luck.
Yeah,
I-
it was
Look.
nice having all of
next
you.
fall.
I just have one more question. On that student survey, were we getting extra points on that?
Yeah, I was gonna put. I was gonna give you guys extra credit for.
How do you know we did it?
Usually, it'll tell me. What I do is I see it gives me a percentage. So if most of you have done it, I just go ahead and give it to everybody. But if nobody does it, it's no. Oh well, too bad.
But I put strong agree and great and everything, so. I'm in.
Same.
Thanks, guys. Appreciate it. But I give them. You have 5 points on the final for doing it.
Go ahead, if you need a haircut, let me know.
Yeah, man. I'm gonna go very soon.
All right, everybody, bye, everyone. We'll see you.
Yes,
Bye,
Got
thank you.
Thank you.
thank you.
Bye-bye.
Bye-bye.
I had a question for you, Mr. Gonzalez.
Mhm.
There was something that like popped up as like we didn't do it. For some reason in the module it comes up as like fall 2020 QEP ISL.
Oh yeah, that's it's not for you guys. They force us to do that every fall, so you are good since it's the spring, right? I don't know what year it is anymore. Let's see.
Sweet.
Yeah, you're
And
good.
then just like I think Justin, like I was wondering about my test 2 grade as well. Cause like it's still in there as like the original thing. I don't know if you went over my paperwork and then the 5.
Maybe I didn't finish it. I guess I'll go back and right now I'm almost done with 3. I guess I'll go back and redo 2. I don't know what's going on.
Yeah, because I was like, oh, that's the same